purpose of this video is to teach you about how to solve multiple argument equations. So our first problem is sine 3 theta equals -1, and the domain is this. So first you're going to replace 3 theta into an x, so it would be sine x equals -1. And then you inverse it, so it would be sine inverse -1 equals x. So then when you look over at our unit circle, for sine, for -1, 3 pi over 2, the sign is -1. So x would equal 3 pi over 2. But wait, you're not done yet. You have to put plus 2 pi k. But if it's tangent, then you have to put plus pi k. Anyways, then you replace the x with the 3 theta because you replaced that in the beginning. So then it would be 3 theta equals 3 pi over 2 plus 2 pi k. And then when you divide, it would be theta equals pi over 2 plus 2 pi k over 3. So you have to add 2 pi over 3 to pi over 2 until it reaches to 2 pi, and it can't go over 2 pi because that's its domain. So we start adding 2 pi over 3 to pi over 2. So we would have to do common denominators. So it would be 3 pi over, 3 pi over 6. And then plus, and then that would equal 4 pi over 6.
If you plug in 1 for the variable k, you will get the number 2 pi over 3. However, to add this to pi over 2, you must make them have common denominators. So pi over 2 becomes 3 pi over 6 by multiplying by 3, and 2 pi over 3 becomes 4 pi over 6 by multiplying by 2. To get more answers in the arbitrary domain restriction of 0 to 2 pi, you may continue adding 4 pi over 6 to the multiples of pi over 2.
So then that would equal 7 pi over 6, and then you add another 4 pi over 6, and that would equal 11 pi over 6. But you can't add another 4 pi over 6 because it goes over our domain. So the answers would be pi over 2, 7 pi over 6, and 11 pi over 6. Yay!
And now we're going to go over another example. In this one we have 2 theta. So 2 theta is going to get replaced by x as we did in the previous one. So it'll be cosine of x equals -1/2. And then you just make it an inverse, so it becomes inverse cosine of -1/2 equals x. So now we're going to move over here to the unit circle and see where in this circle does cosine equal -1/2. And now that would be at 2 pi over 3 and 4 pi over 3. Okay, so now we have 2 answers for this. X equals 2 pi over 3 plus 2 pi k, as we established before. Now we add in the k, just a reminder, we add in the k to make sure we covered all the different values in the unit circle in which we get -1/2 as an answer. And then we also had 4 pi over 3 plus 2 pi k. K is a variable that can stand for any number that you want to plug in there. So now what we do is plug the 2 theta back in for x, so it becomes 2 theta equals 2 pi over 3 plus 2 pi k, and then again 2 theta is 4 pi over 3 plus 2 pi k, and then we divide by 2, and you guys, you need to remember that 2 pi k, you have to divide this by the number 2 as well. So when you divide this, it just becomes pi over 3 plus, divide 2 by 2, it's just 1, so plus pi k. And then again over here, theta equals 4 over 2 is the same as just 2, so it becomes 2 pi over 3 plus, again, the 2's cancel, so it becomes pi over k. So now we're going to plug in different numbers for k to make sure that we've covered all the numbers within our domain range, or domain, that, so that we get all our numbers. Yeah, okay. So if we plug in 1 for k, okay, well, so we've already established that one possible answer is pi over 3 as seen here. So let me just write it down over here. Pi over 3. And another possible answer is 2 pi over 3 as we see here. Let me write that down. 2 pi over 3. And now to find the rest of our values, we are going to plug in different numbers for k. So if we plug in 1 for k, that would be pi over 3 plus 1 times pi is pi, and if we want a common denominator, we would multiply the entire thing by 3, so that would become 3 pi over 3, and that equals 4 pi over 3. And since this is within our arbitrary domain restriction of 0 to 2 pi, another possible answer would be 4 pi over 3. Now, let's move on to the other one to see whether we can get any more answers from this one. So, if we plug in 1 for this k, that would be 2 pi over 3 plus 1 times pi is pi. However, if we want this to have a common denominator with this, we would multiply the entire thing by 3, and that would become 3 pi over 3, which equals 5 pi over 3, which is another possible value because it's within 0 and 2 pi. So let me write that down over here, and let's move back to this equation and try plugging in 2 for k. So that would be pi over 3 plus 2 pi, but if we want the common denominators, that would be the whole thing times 3, so it would be over 3, and 2 times 3 equals 6. So let me just write that down. 6 pi over 3. And pi plus 6 pi is 7 pi, so that would be 7 pi over 3. And as you can see, 7 pi over 3 is not within our arbitrary domain restriction of 0 to 2 pi, so this does not work. And we are left with our 4 answers, which are pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And now that we've gotten everything, we are officially done.
Okay. Hi guys, so today we'll be doing number 17 out of the book. It's on page 500. And our problem is secant of 3 theta over 2 equals -2. And when you're doing these problems, never forget your domain, which is given. In this case, it would be theta is greater or equal to 0, but less than 2 pi. Okay, so the first step to do this problem, number 1, we make secant into 1 over cosine to make it easier. So you have that, 3 theta over 2 equals -2. Okay, the next step, we're going to change this cosine so that it's cosine over 1 because it's easier to find on the unit circle. So cosine 3 theta over 2 equals -1 over 2. Alright. And then on the third step, what we're going to do is we're going to substitute this 3 theta over 2 with x. And you'll see why in just a minute. So now we have, x equals theta. And then that'll look like cosine of x equals -1/2. Then we're going to look at the unit circle and look at where cosine equals -1/2, which would equal, let's see, cosine -1/2 right here. And as you can see, it gives you two values. So one at 2 pi over 3. So let's see, x equals 2 pi over 3. And we look down here where cosine also equals -1/2. 4 pi over 3. Alright, so next you will substitute, you will substitute these values of x back into your original equation. So basically, this 3 theta over 2 would equal, I'll write it out, 3 theta over 2, which is your x, over here is equal to this x, 2 pi over 3. And also don't forget this value. So 3 theta over 2 equals 4 pi over 3. Also, another really important thing is you don't want to forget your, your period, the period. So for a cosine, it would be 2 pi k. So let's add on the 2 pi k to both equations. Okay. Alright, so then after this, we're going to distribute and single out the theta. So, if we take a look at this one, you're going to multiply this whole thing by 2. So 3 theta equals 4 pi over 3 plus 4 pi k. Okay. And then, of course, you will divide everything by 3. Okay. I don't know if you guys can see that. Probably not. So I'll go to here. Over here. Okay, so theta will now equal 4 pi over 9 plus 4 over 3 pi k. Okay, and of course you do the same thing over here. You would multiply by 2 and divide by 3. So I'm going to do this all in one step. Okay, and I hope this isn't confusing. Okay, over down here, theta equals 8 pi over 9 plus 4 over 3 pi k. Okay, let's see. Okay, can you see that? Okay. So now that you have these values, we're going to find the other solutions because your domain is 0 up here, you see. Here's your domain. We're going to plug in values for k. So let me get another sheet of paper. I'm going to cover that up now. Okay, I hope you guys can see. Alright. So now we have this equation. I'll write it again. Theta equals 4 pi over 9 plus 4 over 3 pi k. So we're going to plug in the values. K equals 0, which of course would go here, make this whole value 0, and the outcome would just equal 4 pi over 9, which of course fits that domain, if you guys can still see it. And now we're going to do k equals 1, so we'll do the equation again, k equals 1, so 4 theta equals 4 pi over 9 plus 4 over 3 pi k, which is 1, so we'll leave it like that. And now we're going to change the denominator so that it equals to this one, 9. So 4 pi over 9 plus 12 over 3 pi, 12 over 9 pi. Since we multiply this by 3 over 3 to get the 9. And this would equal, let me think. Wait. Oh, right, sorry. 16 pi over 9. Okay. Okay. And that fits the domain since 2 pi would equal 18 pi over 9. So this is good. Check. Check. Now we'll be plugging in two values for 8 pi over 9 plus 4 over 3 pi k. And of course, one of our values, when k equals 0, we already know that that will equal 8 pi over 9, because you're going to have a 0 here, and that will make this whole thing 0. So, okay, now we'll go ahead and do when k equals 1. So theta equals 8 pi over 9 plus 4 over 3 pi k. Pi 1, sorry, because k equals 1 now. And of course we're going to make this so they have a common denominator. So this equals 8 pi over 9 plus 12 over 9 pi. And this, of course, equals 20 pi over 9. And we know that this does not work because 2 pi equals 18 pi over 9. Okay, so here are your three answers. Okay. Alright. So the first step that you'll do here is, again, we're going to substitute this inside for x. So it'll look like this. Cosine of x equals -1. And then again, we look to our unit circle, and we look at where cosine equals -1. So let's look. Right here, -1, comma 0. So cosine equals -1 here. So this value would be pi. So x would equal pi. Now what you do is, since you have two values that equal each other, x equals pi and x equals 2 theta minus pi over 2, we're going to set them equal to each other. So pi equals 2 pi minus pi over 2. Okay. And then, of course, we are going to, hold on. Alright, I'm going to move this over here because, remember, this also equals 2 pi k, which I forgot. So 2 pi k over here. And you're going to need this because when we set this equal to theta, the 2 pi k also needs to be affected by your simplifying. So, number 3, we will be moving this pi over 2 to the other side. So 2 theta equals pi over 2 plus theta. Plus pi, my bad. Plus 2 pi k. And that will equal 2 theta equals 3 pi over 2 plus 2 pi k. Because this equals, this equals 2 pi over 2. Okay. On number 5, the next step we'll be doing is we'll be dividing this whole thing by 2. So we can single out this theta. So theta will equal now 3 pi over 4 plus pi k. Because this 2 and this 2 cancel out over here. But of course you still need to distribute that to 3 pi over 2. Alright, so now we have our equation, and we're going to do like what we did last time. So when k equals 1, 0, okay, k equals 0, of course pi over k would equal 0. So theta equals 3 pi over 4 plus pi of 0, and that will equal just 3 pi over 4. And then we're going to do k equals 1. So theta equals 3 pi over 4, oh, excuse that phone, plus pi times 1, which will, okay, let me just turn that off. Actually, I think it'll be over soon. Sorry, guys. Awkward. Okay, so this will equal, well, pi equals, we're going to make this the same denominator, so 4 pi over 4. So you're going to add these two, and then that will equal 7 pi over 4. And we're just going to keep plugging in k equals 2 and 3 because we still have room in the domain. So I'll go ahead and go over here and do k equals 2. So theta equals 3 pi over 4 plus pi times 2. And this, of course, 2 pi, which equals 8 pi over 4. Because we're making those denominators the same. So 8 plus 3, 11 pi over 4. And there we have it. And now we're going to plug in, we're going to plug in k equals 3. So 3, is that still on the screen? Nope, it's not. Oh, let me, okay, I'll just go over here instead. Oh, cross that out. K equals 3. Got it? Okay. Oh, it's slanted. Theta equals 3 pi over 4 plus pi times 3. So this would, again, equal 12 pi over 4 because we're making them the same denominator. So 3 plus 12 is 15, so 15 pi over 4. Can you see that? Nope. Oh, okay. Okay. Now let's go through and mark off what doesn't fit in the domain. So 3 pi over 4 obviously fits. It's less than pi. 7 pi over 4, it also fits. In order for it not to make this easier, we'll have our own little box here. We'll have 2 pi equals, and set it to the common denominator. So, 4, do the math, let me think, 8 pi probably? That equals 2 pi, right? Yes, it does. So, 11 pi obviously does not fit, and of course that will not fit either. So there we have your answer. Yay!
In summary, a general rule to keep in mind is to always substitute the expression inside parentheses with x to avoid confusion while solving the problem.
We cracked the cookie!